Hey guys, welcome back. Now let's get started with our day 9 walkthrough. So here the learning objectives are the foundations of analyzing malware samples safely, the fundamentals of .NET binaries, the DN spy tool for decompiling malware samples written in .NET, building an essential methodology for analyzing malware source code. Malware handling. As mentioned, handling malware is dangerous because it is software explicitly designed to cause harm, steal information, or compromise the security and functionality of computer systems. A sandbox is like a pretend computer system that acts like a real one. It is a safe place for experts to test malware and see how it behaves without any danger. Having a sandbox environment is essential when you're conducting malware analysis because it stops experts from running malware on their actual work computers, which could be too risky and harmful. A typical environment setup of malware sandbox contains the following: network controls, virtualization, monitoring, and logging. Now let's go ahead and fire up our machine. Introduction to .NET compiled binaries. .NET binaries are compiled files containing code written in languages compatible with the .NET framework, such as C#, VB.NET, F#, or Managed C++. These binaries are executable files or dynamic link libraries. They can also be assemblies that contain multiple types and resources. Compared to other programming languages like C or C++, languages that use .NET such as C# don't directly translate the code into machine code after compilation. Instead, they use an intermediate language like a pseudocode and translate it into native machine code during runtime via common language runtime environment. This may be a bit overwhelming. In simple terms, it's only possible to analyze a C or C++ compiled binary by reading its assembly instructions. Meanwhile, a C# binary can be decompiled and its source code retrieved since the intermediate language contains metadata that can be reconverted to its source code form. DNSpy is an open source .NET assembly, debugger and editor. It is typically used for reverse engineering .NET applications and analyzing their code, and is primarily designed for examining and modifying .NET assemblies in a user-friendly interactive way. It's also capable of modifying retrieved source code, setting breakpoints, or running through the code one step at a time. So now let's go and open up a DNSpy. Now let's go and open our compiled malware file. Select all files here. So now we have a file. Let's open it. So now we have selected a compiled program and DNSpy is recreating the source code. So here we have our executable file. Okay, so here we have a program. So when we clicked here on the program, it decompiled it back into its approximate source code. So if you're familiar with coding, you should know that the main file is where the program starts from. On the left side here, we can see various functions that are used in this program. Let's start with getIn. Here this function is taking URL as an argument and creating a web request to this URL, and then it returns whatever is found on the website. So here the user agent is also specified. Now let's go and check the postin function. This function has two arguments, the URL and the data, and it is using post method here. So what it does is, it sets up the code required to post the data provided as argument to the web server. Now let's go and check the sleeper function. So this is simply specifying how long the program should sleep for. Now let's go and check out the execute command. Here this function takes command as the argument, and then it starts a new process. And here the window style is given as hidden. And then it manages to open the CMD, execute the command provided as the argument. Now let's go and check our encryptor. So basically an argument is passed as plain text, and that is being encrypted using the key. This is the key here. Now let's check the decryptor. So similar to the encryptor, what the decryptor does is it takes the encrypted data and decrypts it. Now let's go to our implant function. So this function here takes URL as an argument, and then it goes and gets whatever is there in the URL. And once it gets the data, and then it converts the data from base 64, and then it stores it into bytes. and then it is written into the application data folder as pykit.exe, and then it checks if the file exists. If the file exists, it returns the file, otherwise it returns an empty string here. Now let's go back to our main program. Okay, so first this program gets the host name, then it is provided with a string which is the C2 server. Then we have URL which contains the C2 server added by \reg, and then we have the data which gives the host name. So here we have string 2 which posts the host name into this endpoint, and here we have the count variable which is initialized to 15,000. It is 15,000 milliseconds, so it is basically 15 seconds. And then we have the boolean flag which is set to false. And then our for loop starts here. This is an infinite loop. So first the sleeper function is called with the count variable. So the program will sleep for the first 15 seconds. And then it wakes up and checks if there is any task assigned in the task endpoint. So after retrieving the data from the task endpoint, it checks whether it is empty. So if it is not empty, then the decryptor function is called to decrypt the data. And here it checks what the decrypted data is, and then it performs accordingly. Now let's go ahead and try to answer our questions. What HTTP user agent was used by the malware for its connection request to the C2 server? So here we have our user agent. Let's copy this, paste it here. What is the HTTP method used to submit the command execution output? So once the command is executed, the post function is called to post the output to the web server. So the method is post. What key is used by the malware to encrypt or decrypt the C2 data? So let's check the encryptor function here. So as you can see here, we have the key. What is the first HTTP URL used by the malware? So that was that of the C2 server. Let's go to main. So as we can see here, here's the first request. So URL, which is C2 server /reg. How many seconds is the hard-coded value used by the sleep function? So that is 15,000 milliseconds, which is 15 seconds. What is the C2 command the attacker uses to execute commands via the cmd.exe? So if you remember, the commands were executed using the execute command function. So we'll have to go to main and find out where this is used. So here we have found the execute command. So as you can see here, the shell command is used. What is the domain used by malware to download another library? So we need to find out where the implant is being invoked in the main function. So this is the URL used. And since we only need the domain, let's copy stash.macready.thm. So now we have completed our day 9 walkthrough. Thank you for watching my video and stay tuned for more.